All right, good morning, everybody. So happy Friday. Yay, weekend na, no? But before we dive into the weekend, mag-usap-usap muna tayo about Math 151. So today we'll continue our discussion about Math 151. But just a quick recap, last meeting, we just took a look at the different classifications of ordinary differential equations. Ano yung ibig sabihin ng order ng isang differential equation? Kailan homogeneous isang ordinary differential equation? Kailan siya linear, right? And what do we mean by a solution to an ordinary differential equation? And I guess we ended up with a slide showing the four questions that we want to answer when we try to solve or analyze an ordinary differential equation. First is a question about the existence of a solution. Meron bang solution na nag-exist? So basically, we will hopefully today, or if not on Wednesday next week, we'll have a theorem that will tell us kailan merong solution ng isang ODE. And we will limit ourselves to considering such ODEs for the remainder of the course. Kasi nga medyo methods course itong Math 151. We'll try to develop solution schemes in answering different ordinary differential equations. And then the second question is, ilan yung available solutions, right? The ideal case is that there should only be a unique solution to an ODE, pero you know that simple ODEs will have infinitely many solutions because basically, if you have, say, a simple ODE, halimbawa, dy over dx equals x squared. So you're asking what is the function y whose derivative is x squared. So the answer by simple integration will give us 1/3 x cubed plus any constant c. So there would be an infinity of solutions. So one way to get a unique solution is that if we impose some additional conditions to that particular problem. So to get a unique solution. So ang tawag natin doon mga initial value problems or boundary value problems because ODEs on their own may not have a unique solution. So pag dinagdagan natin siya ng isang additional constraint, then posible na tayong magkaroon ng unique solution, right? Third question that we want to answer is, what are these solutions like? Anong itsura ng mga solutions? So usually there we will do a qualitative analysis. And titingnan natin ano yung posibleng maging itsura at properties ng mga solutions na yun, even without solving the ODE right away. And then the fourth and the last question, which is usually the focus of methods courses, ay yung paghanap ng solution ng mga ODEs or the representation for these ODEs, be it via a symbolic calculation, an analytic solution, or through numerical simulations. So yun yung apat na aspeto ng ODEs na gusto nating tingnan sa buong course. As I mentioned, most courses rely on the fourth step. Nagko-compute lang ng solutions. But since this is a higher math course, titingnan din natin yung ibang aspeto, yung tatlong ibang aspeto ng OD, especially the qualitative analysis, because if you'll be working on building mathematical models for certain phenomena, kapag ka nag-OR na kayo, nag-AS or even in pure math, minsan hindi natin kailangan yung actual solution. Gusto lang natin ng qualitative description of these solutions. All right? At yun yung titingnan natin as we go along the course. All right? I think Syra is raising her hand kanina. Gawa ba yun ng share screen? So I just restarted my my screen. So hopefully you can see it now. I'm flashing a Math 151 PDF. So yeah. So for today, we'll look at family of curves, right? So I already uploaded this in the in Canvas under Module 1. So you can have a PDF copy of this. Pero siguro mag-annotate ako today dun sa PDF para makita natin yung solutions na ginagawa by hand. Pero the PowerPoint solution is already there in Canvas along with a simple MATLAB command, MATLAB code na pwede natin gamitin when we talk about isoclines and direction fields. All right. So, but for now, let's look at family of curves because we have said earlier that ODEs might have infinitely many solutions. And the solutions that we're looking for ODEs are basically functions. Ano yung mga functions na nakakasatisfy ng differential equation. And when you're talking about functions, minsan mas okay na makita natin ano yung graph ng mga functions na ito o ng mga solutions dun sa ODE. And since there could be an infinite number of functions that can satisfy a certain ODE, sometimes it is good to look at the family of curves represented by this ODE. So kung meron kang ODE na infinitely many solution, then you will get a lot of functions that satisfies that differential equation, and you can generate a family of curves using this family of solutions. And it also works the other way. If you have a family of curves, chances are we can find an ODE that will represent this family. So siguro we'll focus more on the latter by starting with a family of curves and see if we can find an ODE that represents that class or family of curves, right? So at the end of the lecture, you should be able to obtain a differential equation for a family of curves. So I'll give you a class of curves or a class of functions. Hahanapan natin ng ODE na magre-represent doon sa family na yon. Ibig sabihin, lahat ng members ng family of curves or family of functions na yon ay nakakasatisfy ng ODE. But it's not an if and only if statement. I am not saying that only those family belonging to the family of curves can satisfy the differential equation. There could be exceptional cases wherein there is a special curve, not of the particular form we intend, pero nasasatisfy niya rin yung differential equation. And it is also the case na posibleng meron kang family of curves na wala namang ODE na nakakapag-represent sa kanila. But we'll look at a very nice set of examples today na meron tayo laging mahanap na ODE para dun sa family of curves. Now, let's just review a general solution of an nth-order differential equation. So kung meron kang explicit form, remember ang tawag natin dito ay explicit form ng ODE because we have the highest order term, the nth derivative. Kung order n yung differential equation, ibig sabihin somewhere in your DE, you can find an nth order derivative. All right? So makita natin siya dyan, tapos kaya natin siyang i-isolate sa isang side ng equation. That's what we call the explicit form of the ODE. Right? So yan yung explicit form. And then if it exists, yung solution na yon, yung general solution, ay kaya nating isulat in terms of this. Hold on. Nag-freeze ba yung ano, yung sinishare kong screen? Or can you see na ba yung text ng screen? Delayed siya dun sa laptop ko. Bagal na naman ang internet ko siguro. Nakita nyo na ba yung if it exists na word o na phrase?
Hindi po, sir.
Okay, sige. Delayed na naman siya. So, hindi PowerPoint ko yung may problema. Internet ko yung may problema. Hold on, guys. Yeah. Tinry kong mag-i-PDF yung PowerPoint. Pero, yeah, hindi pa rin siya kinakaya ng internet ko. Yeah, let me restart sharing. Kaya hirap ako kapag ka 10 to 11:30 peak hours ng paggamit ng internet. So, yeah. Okay, there you go. So, a general solution to an nth order differential equation in explicit form. So, ito yung ODE natin. Kung meron siyang solution, pwede raw natin siyang isulat in this form. Y of x equals a function y in terms of n parameters. So si C1, si C2, hanggang si Cn ay mga parameters representing specific numbers. So kung meron kang nth order differential equation, you can find an infinity of solutions or an infinity of general solutions. Actually, hindi pala infinity of general solutions. You can find infinitely many solutions, pero you can write it in such a form, in a generic form, that is dependent on n parameters, C1, C2, and Cn. And if you assign specific numbers to C1, C2 until Cn. Pag binigyan mo ng value yung mga parameters na yan, you'll get a particular solution. So for instance, going back to our example earlier, if we consider the explicit equation dy over dx equals x squared, all right? We know there's an infinity of solutions here, pero madali lang itong isolve. Nakita nyo na to sa 30 series. Isa siyang separable differential equation that can be solved by simple integration. So you get y equals x cubed all over 3 plus the arbitrary constant c. So this guy is a first order differential equation. Tapos sabi, so ibig sabihin ang n natin dito ay 1. There is a solution. Actually, there's an infinity of solution of the form x cubed over 3. And the plus c that we see here is what we call the parameter. So siya yung C1 dito. Kasi order 1 lang siya, so ibig sabihin isa lamang yung parameter para dun sa solution. If you have an order 2 differential equation, you might have 2 arbitrary constants involved that are independent from each other. And the higher the order of the differential equation, the more parameters that you can have in the solution. In fact, an nth order differential equation might accommodate up to n parameters. And if you give specific values to this n tuple of parameters, you will get a particular solution. Right? Tapos titingnan natin ngayon, paano kumuha ng ODE galing sa parameters. Right? So as a remark here, this is what I'm saying earlier, an n-parameter family of curves may be represented as the solution set or a subset of the solution set of an ODE of order n. So kung meron kang isang family of curves na merong n arbitrary constants, then that family might, all right, take note, ang ginagamit kong term ay might. That n-parameter family of curves might be represented by an ODE in the sense that that n-parameter family of curves is part of the solution set of that ODE of order n. So kung ano yung number ng parameters in your family of curves, yun din yung hanapin natin na ordinary differential equation. And the key here is, number 1, we need to identify how many parameters are present in the family of curves. And then second, what we'll do is to differentiate, okay, the given relation or the given function representing the family of curves n times to get rid of all those parameters. Kasi dun sa ODE, wala tayo dapat makikita na parameter. Remember, what we'll be doing here is a little bit of the inverse nitong usual solution scheme. Kasi for the remainder of the course, we'll start with an ODE, tapos kukuha tayo ng general solution. Yung general solution natin, meron siyang n parameters na involved. Now, as a starter, ngayong introductory week natin sa ODE, baliktad yung gagawin ko. Alright? So mag-start ako sa family of curves na meron siyang mga arbitrary constants or parameters na kasali. Ang gagawin ko, maghahanap ako ng ODE na magre-represent sa kanila. Alright? Tapos ang key, so ito yung given sa inyo, ang goal natin matanggal yung mga yung mga parameters by differentiating. That's the goal. Because the ODE doesn't involve the parameters. Yung parameters nag-appear lang siya kasi nga generic yung solution. There are infinitely many solutions. But if you have an n-parameter family of curves, gusto nating mahanap yung ODE na mag-represent sa kanya. So we need to get rid of the parameters using differentiation. So if you have an a parameter family, i-differentiate lang natin yung relation representing that family n times to get rid of all the constants involved. All right? So that's the general plan of action that we'll do. And siguro, let's start with a quick example here. Okay, so the equation x minus c quantity squared plus y squared equals c squared, where c is not equal to 0, is an example of a family of curves. It is actually a one-parameter family of curves because there's only one arbitrary constant here. The arbitrary constant here is the number c, right? The only restriction on c is that c is not equal to 0, right? So do you guys remember what type of curve is represented by this equation of, or by an equation of this form? Anong klaseng family of curves yung meron ako dito? Can you describe it geometrically? Ano yung graph? Pag nagbigay ka ng specific value for C, ano yung graph na makukuha natin? Thank you, Chriselle, Kiefer, and Rensis. Yes, it's a family of circles, right? So, kasi nga, pag nagbigay ka ng specific C, halimbawa C equals 1, kapag kasi C ay equal kay 1, magkakaroon tayo ng x minus 1 squared plus y squared equals 1. Can anybody describe what this circle is? Geometrically, alam na natin na circle, pero in particular, what specific circle or which specific circle does this represent? It's a unit circle, yes, because its radius is 1. Thank you, Keith, or Key and Keith. Pero more particular, not just a unit circle, kasi ang daming unit circle, right? In particular, what is this unit circle? Tingnan, kung tandaan niyo pa yung analytic job. Yes, Victor, when we say unit circle, that's a circle with radius 1. Yeah, that's what I'm looking for. Thank you, Rensis. Siya yung unit circle whose center is at 1, 0. Remember, ang general form niya, x minus h squared plus y minus k squared equals r squared. So pag nakakita ka ng equation na ganito yung itsura, it's a circle with center at h, k, and the radius is r, right? So basically, this circle is the unit circle centered at 1, 0, because here h is equal to 0, here k is equal to, h equals 1, k equals 0. So we have the center at 1, 0, and then it's a unit circle. So, yeah, galing ko mag-drawing ng circle. Pero that's the first curve, right? So if you want to get other members of this family of curves, you just give specific values for C. When C is equal to 2, you get the circle centered at 2, 0 with radius 2. All right. So in general, this family of curves represent the family of circles with center at C, 0 and radius C. All right. Where C is a positive number. Okay. Actually, C can be negative din pala kasi C squared pala yung nandito. So the better description here is that this is the family of circles with center at C, 0 and radius the absolute value of C, right? So some more examples, right? I have here a bunch of representatives of this family. The first one is what we saw earlier, C equals 1. Nag-graph ko na yan kanina, so pero replay natin. Center at 1, 0, tapos ang radius niya ay 1. Tapos the second one, review na lang ng graphing. This is a circle centered at 2, 0. So here's the center of the next circle, and the radius is 2. So radius niya ay 2. So ibig sabihin ganito dapat yung itsura niya. Okay, and then the third one, the center is at 3, 0. That's the center. The radius is 3. So that means it should be this big. Oops. Yan, kunwari sakto. All right. So basically, pwede pa pala natin itong i-describe to be the set of circles who is tangent at the y-axis. Right? Kasi ganun yung parang nagiging itsura niya. All right? So if you want more members of the family, you give specific values for the parameters C. Right? Now our goal is to have an ODE that describes this one parameter family of circles. Right? So again, the goal is to eliminate the parameter C. Luckily, isa lang yung parameter na kailangan nating tanggalin, si C lamang. And how do we do that? We will differentiate the given relation one time, kasi ang n ay equal kay 1, and hopefully there, the constant will vanish. All right? Because again, the general rule or the general approach, if you have an n parameter family, we need to get rid of all of those n parameters dahil gusto natin ng ODE na mag-represent sa family na yon, ang kailangan natin gawin, mag-differentiate para ma-introduce yung derivative into the picture. Right? So let's do that here. Hindi ko pa pala siya ginawa for this particular example kasi baka komplikado yung computations. But you can try this one out. I think you'll get what? dy over dx equals, yeah, I forgot what the answer to this one. Siguro papa-homework ko na lang. Gawin muna natin itong isang example. Simulan natin sa madali, yung simple yung calculations. So let's start the examples by looking at an ODE that represents the family of lines with equal slope and y-intercept. So ano yung itsura ng equation ng family of lines with equal slope and y-intercept? Remember, the general form for the line, or for the equation of a line, is y equals mx plus b, right? So m is the slope, at alin dyan yung y-intercept? The y-intercept is the value of y when x is 0. When x is 0, so y equals b, so this is the slope. Thank you, guys. B is the y-intercept. That's right. Pero ang sabi rito, dapat daw magkaroon tayo ng family na equal yung slope at saka yung y-intercept. Without this condition, yung y equals mx plus b, it's a two-parameter family. Kasi unang parameter mo yung slope, pangalawang parameter mo yung y-intercept. Pero in this particular problem that we're considering, yung slope daw at saka yung y-intercept dapat equal sa isa't isa. So we can reduce this into a one-parameter family. So we'll just be interested with lines of the form mx plus m. Kasi equal daw yung x-intercept doon sa equal yung slope doon sa y-intercept. So this is the family of lines na hahanapan natin ng ODE na magre-represent sa lahat ng miyembro ng ODE and lahat ng miyembro ng one-parameter family na to. Dahil ito ay one-parameter family, we need to get rid of that one parameter by differentiating once. Right? Bakit, sir, nagdi-differentiate para mawala si M? Baka naman posibleng may ibang paraan para mawala si M. I want to differentiate because remember, the goal is to find an ODE that will represent this family. There could be several ways on how to eliminate the variable or the parameter M. Pero ang gusto ko maka-come up ng ODE because we're looking for an ODE that can represent this family. All right. So if that's the case, then we'll start with the given equation, the parametric representation of the curve, and then we differentiate once. So doing so, we'll get what? We'll get y prime equals derivative ng mx, that's m, derivative ng m ay 0, so y prime is equal to m. So here it is understood that y is the dependent variable and x is the independent variable. We take the derivative, and no surprise here, the derivative is simply the slope, right, of the line. Y prime equals m. Now here, sir, hindi pa nawala yung parameter. Pero here we have a representation for the parameter m. The parameter m lang pala represents the derivative of the function y. So that means if I go back to the original equation, I can replace all mentions of the parameter m by y prime. Pag pinalitan ko si m by y prime, then the parameter is gone. But this time we'll see y primes scattered all throughout the given equation. But that's fine because we have eliminated the parameter and we already have an ordinary differential equation. So again, what I'll do is to replace all m's in the given equation for the family by y prime. Kasi yun yung nakuha natin mula dun sa pagde-differentiate. So that means the family of lines can be written as y equals y prime x plus y prime. Okay, and now the parameter is gone. Napalitan yung parameter by the derivatives. And this is perfectly fine because again, we're looking for an ODE that represents the family of curves, right? Now we can write it in a much better way by factoring y prime on the left side. And then we can write it in explicit form and say this is equal to y prime equals y over x plus 1. So this is an ODE that represents our one parameter family. So meaning, if you solve this ODE, you will get lines of the form mx plus m as a solution, where m can be any real number. Okay? Are there any questions with this example? Okay lang ba? Kayang-kayang gawin, ano? Siguro pwede ako magpa-homework nito, no? Kasi madali lang siyang gawin. Mag-iipon na tayo ng points. Gagawa tayo ng mga madadaling homework, ano? As early as now. Alright? So let's consider some more examples. Ang dami kong slides na ginawa para mag-solve. Maiksi lang pala yung solution. But of course, ano yung itsura ng family of lines? So kung gusto nyo makita graphically, so you just give specific values for m, right? So m equals 1, we'll have the line y equals x plus 1. So that means I need 2 points when x is equal to 0, y is equal to 1. And then if x is negative 1, get this. So that means this is, this is one member of the family, which is obtained when m is equal to 1, m equals 2. So you get y equals 2x plus 2. So that means what? 2x plus 2. So when x is 0, y is 2. When x is 1, we get 3. So sorry, we get 4. Ito naman yung itsura niya. 1, 2. Sorry, sobra pala. Okay, and so on. All right, so you give specific values. Oh, by the way, the parameter need not be integer values. So you can choose m equals 1/2, m equals 1/3, m equals 2/3. Because remember, the parameters without any restriction by default is construed to be any real number. All right. And then if you want to get more members of the family, you just give your favorite number, favorite values of m para makakuha na kung ilan man yung kailangan yung members nung family. Right? Now, off to a more interesting example. So here we want to find an ODE for the family of cubic functions, x cubed minus, actually hindi pala cubic kasi naka-implicit form ito. So ang gusto nating curve ay x cubed minus 3x squared y equals c. Right? So ilan yung parameters dito, guys? Ilan ang parameters sa equation na to? All right, thank you, Chriselle and Zaira. Yes, it's a one parameter family. The only parameter here is C. Sorry, kahit obvious sumagot kayo para sa recitation, ano? Kahit obvious tinatanong ko para may time akong uminom ng tubig. But anyway, yeah, it's a one parameter family. So if you want to eliminate the parameter and find an ODE that will represent this family, we need to differentiate once. Okay. So we start with this. Okay. But this is in explicit form. In implicit form. So better recall how to do implicit differentiation. But again, our assumption in class, I see y yung dependent variable, and whatever the remaining variable is, that is the dependent variable, right? Kaya minsan mas okay yung Leibniz notation kasi sa Leibniz notation mas clear kung with respect to which variable tayo nagde-differentiate, okay? So let's differentiate this equation at least once and see if we can eliminate the constant. All right. So in this particular case, we differentiate with respect to x. So we get 3x squared. Tapos this guy is or will require the product rule because remember, y is not a simple variable. It's not a constant. It is a function that depends on x. That's part of our assumptions, right? Y is a function of x. So that means 3x squared times a function of x. Para ma-differentiate yan, we need to use the product rule, right? Minus the sum na manggagaling sa product rule. So remember how to differentiate the product. So we copy the first, 3x squared, differentiate the second, dy over dx, plus copy the second, differentiate the first factor. So we're going to get 6x equals luckily 0. Dito lucky tayo kasi si C ay wala nang kasamang ibang variables. So that is just a constant, that's a parameter. So magzi-0 lang yung derivative niya. And is it fine? Yes, because here we don't have any arbitrary constant anymore. We don't have any parameter left, and instead we have a derivative. So it's just, or it will just boil down to simplifying this ODE. So we'll have 3x squared minus 3x squared dy over dx, or maybe you can just write it as y prime para mas maiksi, plus 6xy equals 0. And then if you want to write it in explicit form, we'll have y prime equals negative 6xy minus 3x squared over negative 3x squared. Tama ba? Negative 6x minus 3x squared minus 3x squared. So this could be written as what? Biglang nag-algebra, no? Pwede itong maging 6, so pwede itong maging 2. Pwede kong cancelin yung x. Oh, now you can just leave it as 2y plus 3x over x. Tama ba? Pinansel ko yung x sa taas, x sa baba. Oh yeah, thank you, Billy. Yeah, there should be a minus nga pala kasi nag-distribute ako ng minus doon. So this will be a positive and this will be a negative. So our implicit form is y prime equals 3x minus 2y all over x. All right? Is that correct? Do you agree with that final answer? Okay, mukhang wala nang objection. So any questions so far? Madali lang, no? Yes, Ira. Question?
Sir, question lang po, yung sa y, kung differentiate po with respect to x, yung y po ay hindi po treated as constant po.
Si y ay hindi treated as constant kasi si y ay hindi constant. Remember, our
Okay po.
assumption ay y is a function of x. Hindi tayo nagpa-partial derivative. Alam natin si
Okay
y
po.
ay equal kay f of x. So ibig sabihin, hindi mo talaga siya pwedeng i-treat as a constant kasi hindi siya independent variable. Our assumption, si y ay function ng x. So be careful with that. Nice question, Zaira. Huwag niyo kakalimutan. Si
Thank you,
y,
sir.
alright, si y ay nakadepende kay x, kaya all those derivative rules will still apply in a complicated manner. Alright? Siyempre, hindi ko kayo papadalian lang. No? Pero again, yun yung assumption. Kaya hindi pwedeng i-treat si y as a constant because it is not a constant. It is a function of x. Alright? So let's move
Sir?
on. Oh, yes. Who's that? Go ahead.
Yung numerator po ata, sir, dapat negative 2y
Plus 1.
plus x.
Yep. Thank you. Kasi kinancel ko nga pala yung 3. Alright? Thank you, Jeff. Okay. Yung mga palusot ko doon lagi, sinetest ko lang kung nakikinig pa kayo. Ano. Pero anyway, yeah, I forgot that I canceled the x. All right, so, okay. Okay na, wala nang objections. Okay, so if none, isa pa. Find an ODE for this family. Y equals ax squared plus bx plus c. Now, again, by default, ang convention natin sa klase, si x yung independent variable, si y yung dependent variable. So that means si y ay nagtatagong function lamang ni x. So maraming mga x's dyan sa loob ni y. So hindi siya pwedeng i-treat as a constant. So in this family, we have 3 parameters, a, b, and c. So basically, ang tanong natin dito, meron bang ODE na makakapag-represent sa lahat ng posibleng parabolas? Tama? Kasi di ba any parabola can be written in the form, or the equation of any parabola is of the form y equals ax squared plus bx plus c, because this is your general quadratic equation. Question is there an ODE that can represent this 3-parameter family of curves? O itong mga parabola, kasi sa parabola, 3 yung parameters. coefficient of x squared, coefficient of x, and the constant or the translating constant. All right? But no worries here, para magawa yon dahil 3-parameter family to, pwede tayong mag-differentiate at most thrice and see if we can eliminate the if we can eliminate the parameters by then. All right? So tatlong derivative to. So first, if this is y, then we get y prime equals what? 2ax plus b. And understandably, there will still be some parameters left. Isa pa lang yung natanggal natin na parameter, si c pa lang. Kasi tatlo yung parameters, so hindi talaga sufficient na isang beses lang tayo mag-differentiate. Or it might not be sufficient to differentiate only once. So kailangang i-maximize natin. Hanggang 3 beses tayo mag-differentiate and hopefully along the way, maubos yung parameters. All right? Now, we get y prime. Kasi meron pang parameter, hindi pa tayo titigil. Derivative this time is what? Derivative is 2a. And then, meron pa rin parameter. Si parameter a natira pa rin. So we move on and use our last possible step. Third possible step, take the third derivative, and that's going to be 0. Right? So basically here, we get d cubed y over dx cubed is equal to 0. Ibig sabihin, any quadratic equation or any parabola is a geometric representation for the solution of the third order homogeneous differential equation y triple prime equals 0. All right? And that's understandable kasi 'di ba natutunan natin pag meron kang degree n na polynomial, ang derivative niya ay magzi-0 starting from the n plus 1 derivative. Okay? Questions? So sana tama na yung ginawa ko dyan. All right? Okay, move on to another example. Saan kung space na nilalagay? Okay. Okay, this one, a more challenging one. Challenging ba to? Let's see. Computationally challenging yata tong example na to. So it is a sum of two exponential functions. So we get y equals c1 e to the 2x plus c2 e to the 3x. Again, y is the dependent variable. It is dependent on the variable x. Then we have this function, and we have constant c1 and c2 that are not determined or not prescribed. So ibig sabihin, this is a 2-parameter family. Ang parameters natin si C1 at saka si C2. Now, dahil 2-parameter family, we can differentiate at most twice and hope that the constants will be gone by then. All right? So let's see. Let's start the process and compute y prime first. So pag nag-differentiate ako ngayon, derivative ng C1 e to the 2x. Remember, C1 is just a constant. It can't take any real number, pero in essence, it's a constant. So its derivative will be 2c1 e to the 2x plus derivative of c2 e to the 3x will be 3c2 e to the 3x. All right? But of course, the constants are still here. Right? Now, let's try another derivative, and maybe that will help. You know? So let's take y double prime. Y double prime will be equal to 4c1 e to the 2x plus 9c2 e to the 3x. All right? Now, at this point, hindi tayo kasing lucky nung previous two examples wherein pag-differentiate kagad, ang dali nating nakita paano mawawala yung arbitrary constants. In this particular case, we might need to solve this system of equation just to get rid of C1 and C2. Because the goal again here is to look for the value of C1, possibly in terms of the given functions of x and the derivatives of y. Kasi yun yung goal. Mawala lang si C2. It doesn't matter if C1 and C2 will be expressed in complicated expressions involving the variable x, involving the variable y, or any of its derivatives. That's fine. Because the goal is to come up with a differential equation. All right? So here I want to solve for C1 and C2 in terms of the other expressions in the in this particular system. So I'll treat it as a system of equations, and probably I can do what? Probably I can do elimination here, right? Tanda pa ba paano mag-solve ng linear system? This system is linear in the variable C1 and C2. Right? So ang gagawin ko lang, mag-elimination ako. Kung gusto nyo mag-Cramer's rule, okay lang din, or substitution. But I'll do elimination. So what I'll do is I'll multiply y prime by -2 so that I'll have -2y equals -4c1 e to the 2x minus 6c2 e to the 3x. Sorry, nawala yung prime. And then I'll just copy the expression for y double prime. And then I'll add them up, right? So I'm going to get y double prime minus 2y prime equals, that's the reason why I multiply the first equation by -2 para makancel yung first term. So the term with the C1 will vanish and we'll be left with what? 3c2 e to the 3x. All right? And then I'm going to solve for C2 in terms of all the other expressions in this equation. So we'll get C2 equals y double prime minus 2y prime all over 3e to the 3x. All right? All good? Tama ba yung solution ko? Let me just put this here kung tama na yan. Okay. All right? All good? Erase ko na yung erase ko na tong solution na to kung tama siya. If something is wrong, just tell me right away kasi mahaba-haba ito, ano? So, okay? Wala namang objection? All right. I now have an expression for C2, then I want to get C1, right? Ano yung natitirang value ni C1? So, pwede ako mag-substitute sa alinman dito sa dalawang equation na to. I'll plug in the value of C1, and then I'll solve for C2, right? So, probably I'll use, say, this equation. From the first equation, I know that what? I can solve for C2. Si C2 ay magiging equal kay, kanino siya magiging equal? Sorry, kay si C1 pala siya. Kasi si C1 pa yung hinahanap natin, no? So C1 will be equal to y prime minus 3c2 e to the 3x all over 2e to the 2x. Right? Alam ko na ngayon si C2. So, ibig sabihin, pwede kong palitan si C2 by the expression that we got earlier. This is minus 3, times y double prime minus 2y prime all over 3 e to the 3x times e to the 3x all over 2e to the 2x. All right? And then we simplify. E to the 3x here will be canceled by the e to the 3x here. So we'll get y prime equals, ito yung ayoko. Magsasolve na magsasolve. Oh, but the 3 here will be canceled by the 3 below, so it is much easier. So going to be minus y double prime plus 2y prime all over 2e to the 2x. Tama ba? Y prime minus y double prime plus 6 plus 2 y prime all over 2e to the 2x. So this will be 3y prime minus y double prime all over 2e to the 3x. Sorry, e to the 2x. So this is our expression for C1. So si C1 ay equal to this guy. Alright? Tapos ngayon, kukumpletuhin ko na yung picture. I know what the value of C1 and C2 are with respect to the derivatives and the ones involving the independent variable x. So I can go back to the original equation. Burahin ko na to. Okay. then I can use these values in the original equation. So what I'll have is y equals C1. I'll just copy this over. Times e to the 2x plus C2 times e to the 3x. And then I can simplify. I'll get 3y prime minus y double prime all over 2 plus y double prime minus 2y prime all over 3. And that's going to be it, right? All you need to do is to just simplify it. Sige na, simplify natin. Magandang exercise. I multiply both sides by 6. So I'll get 6y equals, so magiging 3, 6, 3, 9y prime minus 3y double prime plus times 2, 2y double prime minus 4y prime. Tama ba? Tama ba mga pinagagawa ko pa?
Yes, sir.
So this will become, thank you. So this is going to be 6y equals 5y prime minus y double prime. Or in other words, this is y double prime minus 5y prime plus 6y equals 0. That's our differential equation. This is a homogeneous linear second order ODE. Y double prime minus 5y prime plus 6y. All right? Okay, did you get the same answer? Hopefully tama yung nakuha ko nating solution. You can always check with the PowerPoint slides that were uploaded. Mas gusto ko lang yung ginagawa siyang live kaysa yung slides lang yung ginagamit. Pero there's a there's a chance of human error, ano? Iba ba yung sign? Let's see. Y double prime minus 5y prime plus 6y. Yeah, pa-double check na lang, Victor. Pero I hope the process is good, right? So again, two-parameter family, kaya kinailangan kong mag-differentiate twice. Unfortunately, hindi siya kasing dali ng ibang examples. We cannot find an expression for the parameters in terms of the derivatives and functions of x. Kaya kinailangan ko pa ng system of equations. All right? Nawala yung notes ko kagabi. Pinopya ko yung final answers ko. Kaya lang naiwan ko dun sa aking office dito sa bahay. So, yeah, hindi ko ma-double check. Pero just double check the work, but I hope the process makes sense. So before we proceed, any questions? Kaya nyo na ba na mag-homework na ganito yung gagawin? Okay lang din, Victor, na i-isolate yung y double prime. You could have written as final answer, y double prime equals 5y prime minus 6y. Ang tawag naman natin doon ay explicit form, right? Pag explicit form, naka-isolate yung highest order derivative to one side. Okay. Pero since the problem didn't say any requirement or any form for the final answer, then we're free to choose whatever is most convenient for us. Actually, you could have stopped here. Wala naman sinabing i-simplify. So, pwede na kayong tumigil dito. If you want to be, kung gusto nyong ibida na magaling kayo sa algebra, di pumunta kayo dito. Tapos sabi mo, sir, marunong ako mag-LCD. So, pwedeng dalhin nyo rito. Or, yeah, you can end up with a final answer. Or, if you want to have an explicit form, or kung sinabi na write an explicit form for the ODE representing this two-parameter family, then your answer should have been y double prime equals 5y prime minus 6y. All right? So it's just about how the problem was phrased. Okay? But pero pag walang sinabi, anything is acceptable. All right? Let me see what's left of this slide presentations. Oh, yun pala. Practice exercises na. Okay, so mabilis lang pala to. Akala ko abutin ako ng isang meeting para rito. Pero yeah, probably let's have homework number 1. Tama ba? Homework number 1 pa lang tayo, no? So do one of these. Ano? So pili kayo ng isa dito sa A, B, C, and D, then submit it in a PDF file your solution. Again, the thing is you want to obtain a differential equation for anyone. Isa lang wag nang bida-bida. Pwede nyo namang itry. Ano? Itry nyo sagutan lahat. Pero isa lang yung isubmit nyo dun sa PDF. Ano? Bahala na kayo kung ano yung gusto nyo gawin. Siyempre, ang pipiliin nyo yung letter D. Ano? So, bahala na kayong pumili. So, yeah. I'll announce it in Canvas for the sake ng mga hindi naka-join today or hindi maayos yung connection. I'll announce it in Canvas, pero the instruction is to choose one among these four and obtain a differential equation that represents that family. All right? Any one of these four. Exactly one. Sige na. Choose one and only one among these four and submit. Pero it won't hurt if you will try to answer all four of them, right? I think that's the end of the slides. Sana ganito lang lagi yung topic. Pero you see, it's algebra plus simple calculus. Now, dahil may time pa, siguro muna tayo? 3-minute break. Tapos, lipat ako ng PowerPoint, alright? Okay, see you after the break. Yes?
Before that, sir, when's the deadline of the homework?
Yeah. Thank you for reminding me. Kailan nyo gusto? Do you think you can do it on the 21st? So deadline September 21. That would be Wednesday.
On our lecture time, sir?
Right
On our
before the
class
lecture.
time. Okay, for lecture time. So
gagawin na ang deadline natin ay September 21. Ano nga oras tayo nag-start? 10, no? 9:59 a.m. So deadline for homework number 1 is on September 21, 9:59 a.m. Right? Pero it won't hurt to submit early. Right after the call, I'll draw up the announcement. I'll make the submission bin in Canvas. So as long as you're done, don't wait for the deadline. Upload it right away. All right? Tapos pag wala kasi akong magawa, kahit hindi pa deadline, chinechekan ko na yung mga na-submit na. So the earlier you submit, the higher the chance that you get your feedback early. Ang problema ko kay Canvas, hindi ko pa nahanap yung setting kung paano ko masiset na yung sa speed grader lalabas ay in the order na na-submit. Kasi by default, alphabetical. Alright. So, kaya kapag medyo natambak na yung mga nag-submit, alphabetical ko na sila nakikita dun sa speed grader. Alright. Pero kung kayo pa lang yung solo na mag-submit, halimbawa, mayang hapon, mag-checkan ko siya kagad. So, yan. Okay. Yes, it's up to you. Tinatanong ni Zaira kung ano yung format ng homework. You can pwedeng digitally handwritten. So if you have a tablet, you can write on your tablet and then that's your solution. Kung wala kayong tablet or mas comfortable kayong nagsusulat sa papel, you can write your solutions on paper and then take a picture of it and save it as a PDF. So, ang daming mga apps na pwedeng gamitin. You can use Adobe Scanner. Download nyo sa phones nyo. You take a picture. Kung ilang pages man yon, isi-save niya as a single PDF file yon. Or you can use Scam Scanner. Okay? Pero I think ngayon sanay na tayo sa mga ganung modality. So you can use your favorite PDF converter para sa pictures. And kung talagang extra effort kayo, it's also okay if you submit a typewritten homework, all right? Just make sure that you're the one who did it. Huwag kayong aasa dun sa software na ibibigay na yung solution tapos ika-copy-paste nyo lang. Pwede nyo i-latex or i-equation editor yung solution. That's also fine if you want to have a neat output for the course. That's acceptable with me. But I'll trust that that's your own work. Tapos ngayon, hindi na kasi uubra yung online solver lang yung ginagamit nyo kasi meron tayong face-to-face exams, right? So you'll need to practice doing problems by hand. Okay. na ba yung break? Tapos na yung break. So let's open the last set of PowerPoint slides for this chapter. Yes, no? Tapos na natin yung chapter 1. Baka matapos natin yung chapter 1 within the first official week of the class, ano? Hindi pala first official, yung first na totoong week ng classes, all right? So basically in this particular section, we'll be looking at sort of the qualitative analysis for solutions of ODEs. Kanina natutunan natin kapag ka meron kang family of curves, nakahanap tayo ng ODE that will represent that n parameter family, right? Now, usually baliktad yung gagawin natin dito sa course. Given ka na ng ODE, hanap tayo ng solution para dun sa ODE na yon. And the result, if there are no initial conditions or boundary conditions, what we'll get would be a family of curves. So mula sa ODE, makukuha natin family of curves. Now, yun yung ina-address yung fourth question dun sa pinaka-framework natin. But sometimes it's also good to take a look at how the solutions look like without actually solving for the solutions. Tapos yun yung laman nitong third section. We'll look at a qualitative description of the solutions to our ODEs. And for that, we'll look at direction fields for a particular solution, right? Now, so titingnan natin yung geometric interpretation ng isang first order ODE. Of course, you can do this analysis for higher order ODEs, pero mas mahirap na. Makikita nyo later kung bakit mahirap i-interpret pag mas mataas na sa 1 yung order ng ating ODE. But for now, our goal is to understand the concept and solution of initial value problems, not just analytically, but also geometrically. All right. But I don't know if we can finish everything, but let's do what we can do for the remainder of the time, right? So in geometric interpretation ng first order ODE, so assume that we have this first order ODE. So ito yung first order ODE. First order siya kasi ang involved lamang ay y prime. If you look at the operator f or the right-hand side, involved lamang si x at saka si y. Wala ng higher order derivative. So actually, form. So explicit yung form niya dyan. Tapos it's a value problem. Explicit ODE, ibig sabihin there could be a family of solutions. But now we are imposing an additional constraint, an initial condition. What should be the value of the dependent variable y at the initial value of x, which is x of 0? Right? So ito yung tinatawag natin IVP or yung Cauchy problem. Titingnan natin ano yung interpretation ng solution dito sa IVP na to. Now, the right-hand side, if you think about it, so if we think about it, the right-hand side of the ODE gives the slope of the tangent line to the graph of the solution curve. Because here you see you have y prime equals f of xy, but f prime is basically the slope of the tangent line at the particular point x comma y. All right? So remember ang interpretation ng derivative kung meron kalimbawang curve. Sorry, mahilig akong guluhin yung slide. Kasi ganyan din ako pag nagte-take note. Pag nagbabasa ako ng libro, lagi ako merong notes sa gilid para i-drawing yung ibig sabihin ng mga nakasulat. Because sometimes it's easier to analyze or to understand things if you have a drawing of it or an illustration of it, right? So remember, yung derivative, kung meron kang curve, nagsimula ka sa curve, let's say this parabola, yung derivative is simply the slope of the tangent line passing through a particular point on the curve. So say this is the curve, then this is the point of interest, and bawa ito yung x sub 0, ito yung y sub 0. Ay, ba't pala ako nagpapakihirap dyan mag-drawing? Pwede dito ako sa isang screen. But anyway, tapos yung tangent line dyan ay ito. Yung tangent line, and then yung slope ng tangent line na yan yung derivative ng function. Halimbawa yung function ko ay g, Yan yung derivative ng function ng, yan yung derivative ni g at the point x sub 0, comma, y sub 0. Now, kung meron kang IVP, ibig sabihin yung derivative ni y nung solution, right? So yung solution curve natin ay y equals g of x. Ang sinasabi nitong IVP na to, ang derivative ni y ay equal doon sa right-hand side f of xy. So basically, our interpretation for the solution, which is sometimes called the integral curve or is represented by the integral curve, this is the collection of points na ang tangent line ay may slope equal to f of x comma y. Right? And with that knowledge, we can have an analysis of the solution of the ODEs even without solving the ODE itself. Right? At yun yung gagamitan natin ng tinatawag natin na line elements consisting or comprising what we call the direction field. Okay. Now, gagawin ko ngayon, sa bawat isang point x comma y sa Cartesian plane that hopefully satisfies the given equation, kukomputing ko ano yung slope sa bawat point. Tapos, ang gagawin ko, dun sa point na yun, magdodrawing ako ng isang maliit na line segment, which we call line elements, na ang slope ay equal dun sa function value ni xy. And the collection of all these small line elements ang tinatawag natin na direction field. So basically, Cartesian plane, magko-consider ako ng isang point x comma y dyan. Ipa-plugin ko yung x at saka y na yun kay function f. So I'll get f of xy. Pero ang sabi, yung function value nung point nung pair of points na nung point na yon under f is basically prime. So ibig sabihin siya ay slope ng tangent line to the curve at the point x comma y. So ang gagawin ko dun sa point x comma y, I'm gonna draw a small line ng slope ay equal doon sa function value ni x comma y under the function f. Kasi nga slope siya ng tangent line equal siya kay y prime. So magdodrawing ako dyan, halimbawa, ito yung line na ang slope ay na-compute ko na value ng f of xy. And I will do this for a lot of points in the Cartesian plane. Kaya medyo matrabaho kung gagawin natin by hand yung direction field. Pero the nice thing about direction fields, it will give us an idea of how the family of solutions look like. All right? Or if you have an IVP, paano natin mahanap yung particular solution by just tracing the direction field. Okay? So kung medyo abstract, itong mga bagay-bagay na to, let's look at a particular example. Okay? At paano siya gagawin, quote, in a human way. Ano? Paano-mano. Una, kung meron tayong given okay. So given yung y prime equals f of x comma y, right? What we'll do is to pick a. Kasi ang gagawin ko ay bubuin ko yung c equals f of xy. Right? So ibig sabihin, papalitan ko lamang yung si y prime by c. Nagsimula ako sa y prime equals f of xy. I will pick a constant that will replace y prime. But I'll just remember that this c is basically the slope. So ngayon, hinahanap ko saan yung mga points na ang slope ay equal dun sa napili ko na c. Ang tawag natin dun sa curves ng equation ay f of xy equals c ay mga isoclines. Kasi ang gagawin ko, ipla-plot ko ngayon yung isocline. Ipla-plot ko yung graphs ng f of x ay yung graph ng f of xy equals c. Tapos ipla-plot ko siya. Tapos along that graph, magdodrawing ako ng mga line segments na ang slope ay equal kay c. Right? So, i-graph niyo muna itong isocline na yan. Pero remember, si c ay y prime. So along the graph of the isocline, magdodrawing ka ng line elements. Ang slope dapat ng line elements na yon ay equal kay c. Halimbawa, ginawa mong c equals 1. So ipa-plot mo ngayon ano yung itsura ng graph ng f of xy equals 1. So meron ka ng graph, halimbawa ito yung graph ng f of xy equals equals 1. Tapos along that graph, magdodrawing ka ng mga line segments. Probably I should use a different color. Magdodrawing ka ng maliliit na line segments. Taba? Oops, bakit ang layo? Line segment ang slope ay equal kay 1. Right? Along that curve. So dun sa isocline na yan, lahat ng line elements mo, ang slope ay dapat equal kay 1. Something like that. Right? And then you will do this for a bunch of different points. Bida-bida ako, meron palang example dun sa slide. Okay. Let's see this particular example. So say we are given the first order ODE y prime equals negative xy. So ang gagawin ko, una muna, gagawa ko ng mga isoclines. To get isoclines, I'm going to select specific values for C. For instance, piliin ko C equals 1. So kapag ka si Ci equal kay 1, so ibig sabihin si y prime, papalitan ko lamang by 1. Okay? So we'll get negative xy. Ito yung f of xy natin kanina dun sa explanation. We'll get negative x over y equals 1. Kailangan ko yung graph ng isocline na yan. So ang tawag dito sa relation na yan ay isang isocline. So i-graph ko yung isocline para i-graph yan. Gusto ko siyang i-simplify. Y equals negative x. So yung isocline na yan, ito yung itsura. Alright? Yung line passing through the origin, ang slope ay negative 1. Pero kailangan ko ngayon yung line elements. Ang gagawin ko, along this isocline, magdodrawing ako ng line elements na ang slope ay equal kay C. Right? Ang slope dapat ay equal kay C. Yan. Kita niyo yung black? Yan yung mga line elements. Kasi dun sa isocline na y equals negative x, ang slope ng mga line elements dapat ay equal kay C, which is 1. Alright? And then you do this for various values of C. Say, I'll use C equals negative 1 naman. Kapag kasi C equals negative 1, una hanapin niyo yung isocline. So I'll have negative x over y minus 1. Pag sinimplify ko yan, y equals x. Y equals x, ayun. So ito yung pangalawa nating isocline. Ito yung isocline when C is equal to negative 1. Pero C is equal to negative 1. So ibig sabihin, ang slope ng mga line elements on this isocline should be negative 1. So magdodrawing ako ng mga maliliit na lines na ang slope ay negative 1. Remember, ang slope ay negative 1 ay yung diagonal na line. Pero yung pa-backslash, alright? So if I do that, I'll get this. And then I'll do this for other values for C. Kapag si C ay papunta kay 0, ibig sabihin magkakaroon lang ako ng x equal to 0, ang slope ay 0, so horizontal yung line. Okay? Or kapag si C ay napakalaki, ang y ay equal kay 0. So essentially, you can give any value of C you want, sufficiently many values of C para makita natin yung behavior noong direction field. Right? So kapag nagkaroon ako ng C approaching infinity, bakit C approaching infinity? Kasi kapag C approaching infinity, that means negative x over y will approach infinity. That means y should be equal to 0. Kaya yung isocline, habang si C ay palapit ng palapit sa infinity, ay yung x-axis. Y equals 0. And along that y-axis, the slope should be approaching positive infinity. Nagiging infinite yung slope kapag siya ay vertical line. Tapos makita niyo ngayon, kaya kong mag-construct ngayon ng solution. Ang solution sa y prime equals negative x over y ay yung curve, alright, mga curves na ang tangent line at their particular points ay equal doon sa mga nakadrawing na line elements. So meaning, ang mangyayari dito ay, halimbawa, isang solution. Let me use a different color again. Purple. So ito ay isang solution. Itong circle na to. Bakit siya naging solution? Kasi ang tangent line dun sa mga points sa circle will exactly coincide with the line elements that we just draw. that we just drew, right? So, and then kung kailangan mo ng solution that will pass through here, halimbawa, ang initial condition mo, ang y of 0 ay equal kay 1, 2, 3, 4, right? Ibig sabihin, yung solution mo dapat dadaan dito, pero ito yung tangent line, or that's a representation of the tangent line at 4, 0. So, ibig sabihin, susundan ko lang yan. Yan dapat yung slope. Tapos dadaan siya dyan. Dadaan siya dyan. Basically, circle pa rin siya. Pangit lang yung drawing, pero dapat circle siya. Alright? Do you guys get the idea? Maganda yung idea, pero mahirap siyang gawin the human way. Ano? Kaya maganda yung isoclines o yung direction fields. Kasi sa direction fields, nagpa-plot ka lang ng mga slopes, nagkakaroon tayo ng idea how the solution will look like. Pero it's quite tedious to do because you have to give a sufficient number of values for C. Ibig sabihin, marami ka dapat isoclines na pino-consider. Alright? Tapos it's a pain to draw line elements. Tapos yung slope, tatansyahin mo lang sila. Alright? So that means, mahirap siyang gawin by hand. So it's better to do it using computers. Pero anyway, I think there's a clearer explanation to this. Medyo pinangunahan ko yung slides. Ginawa ko siya manually. Madalas ko yung gagawin. Alright? Pero minsan nasa slide naman siya. Okay, pero ito yung sinasabi niya kanina. And this is a nicer representation for the direction field. Okay, now, it's not ideal to do this by hand, okay? Lalo na kung medyo komplikado yung expression, mahirap mag-compute ng isoclines. So we might ask our computers to do the job for us. Okay, so but basically direction fields and integral curves are geometric representation of the solution. Kung meron kang y prime equals f of xy, it can be thought of as the geometric equivalent or the analytic equivalent of a direction field. Kasi lahat ng solutions or yung behavior na dinidescribe ng ODE ay nakikita natin by looking at the direction field. And then if we want to get a solution, pwede mong isolve. Humanap ka ng solution ng function phi, a continuous function phi that will satisfy your first order differential equation. Now, graphically, we will have a solution representing that solution phi. Yun yung nag-graph natin, right? So if you're doing an analytic solution, so magsimula ka sa ODE, gamitin mo yung mga techniques na matututunan natin sa klase, you'll get the solution phi. That's purely an analytic solution. Now, if you are more graphical or meron ka magandang software na mag-graph nun, yung ODE pwede siyang i-translate into a direction field. Pag meron ka ng direction field, kailangan mo na lang i-trace ano yung nangyayari dun sa direction fields to get an integral curve, which is a solution or a representation for the solution to the ODE. Right? Kaya lang mahirap nga yung paggawa ng direction field, so we can ask our computers to do the direction field for us, right? Paano ito gagawin ng computer? Dahil computer siya, kaya niya mag-compute ng maraming points. So, hindi mo na kailangan dumaan sa isoclines. So, ang gagawin mo, pwede ka na mag-pick ng arbitrary points x, y in space, right? Or in the two-dimensional Cartesian plane. Hatiin mo lang siya into a mesh of points. Usually, equally spaced yung gusto natin para equally spaced. Dapat may d. Para makita natin, para mas makita natin mga pair of points x, y, e na y prime equals f of xy, i-plugin mo lang si x at saka yung y value na pinili mo, i-plugin mo siya kay f, we will get the slope line passing through that particular point x, y. And we will use that information para makapag-draw ng line element. Yung line element again, maliit na line na ang slope ay equals to f of xy. So if you'll ask your computer to do the direction field for y prime equals negative x over y, yung example natin kanina, ito yung i-output niya. Right? And then mas maganda siya kasi makikita mo, talagang circular kasi makikita mo yung circular behavior ng mga solutions. So if you want a solution passing through here, kailangan mo lang i-trace yung behavior niya. Dapat yung mga line elements, sila yung tangent line. Medyo naduling ako sa pagsusulat. Pero I hope you see the picture, right? Burahin ko na nga lang kasi makita yung pattern even without that annotation. Alright? So I still have 5 minutes, so probably I can demo the code that I shared with you. Dun sa module, meron akong MATLAB code na shinare. So if you have your MATLAB already with you, download that small M file and then run. Explain ko siguro kung saan ang galing yon. So I hope you can see my MATLAB screen now. Okay. Ito ay 13 lines lang with some vacant lines, ano? Para na direct answer. Sabihin ko kung ano yung ginagawa line by line. So yung line number 3, nagko-consider siya ng points. Di ba yung step number 1 dun sa computer way, create equally spaced points x, y, or a grid of equally spaced points x, y. Command such a so ibig sabihin my x values will start from -2 papunta kay 2, ang increment ay 0.2. So that means I'll start from -2, then I'll jump 0.2 unit per step hanggang makarating ako kay 2. Yun yung mga x values ko. Tapos ganun din, for the y values, I'll start from -2, tatalon ako 0.2 unit per step hanggang makarating ako kay 2. Tapos yung mesh grid command, siya na yung gagawa ng trabaho sa atin para gumawa ng isang rectangle consisting of points from x equals -2 to 2 and y from -2 to 2 na ang increment ay 0.2. Right? Pwede yung paglaruan. Itong nasa loob ng mesh grid na yan. Pero yun yung idea. And then this line will assign that mesh grid to x, y. So si x, siya yung -2 to 0, -2 to 2. Si y naman, siya yung y values, -2 to 2. Alright? And then sa line number 5, dito nyo ilalagay yung function f na nandun sa ODE. Remember, yung ODE natin ay equal kay -x over y. Ang isang bagay about MATLAB, nag-work siya with vectors. So kapag gusto natin kunin yung x over y, yung magka-partner na x at saka y, i-divide natin sila. Meaning the first component, the first x value should be divided by the first y value. The second x value be divided by the second y value and so on. Ang command doon ay, syempre -x kasi -x over y, yung f prime ay yung y prime natin. Tapos pag gusto kong gawin yung division term by term, ang command ay .divide. Kasi si x ay vector na laman niya ay mga numbers from -2 to 2. Si y ay another vector na ang laman niya ay -2 to 2. If I want to do component-wise division, ang command ay slash. So -x .divide -y. So yung first component ni -x, i-divide niya lang by the first component of y and so on. Okay? Yung line number 6 ay paki-delete yung line number 6 kasi para yun sa ibang function f. Basta yung f, siya yung right-hand side ng first order ODE nyo. Tapos si line 7, kukomputin niya lang yung scaling factor. Kasi di ba gagawa tayo ng maliit na line element, so dapat maliliit lang. Kasi pagka hindi ko siya ini-scale, posibleng ang lalaki ng mga lines na makukuha ko. And then lines 9 to 12, generates the direction field. Basically, quiver yung ginagamit niya. Quiver or the quiver command and what it does, you just right-click on it. Tapos, pwedeng help. Ano ba itong help dito? Yeah, help on quiver. Alright? Gusto nyo makita yung ginagawa niya. Pero, kung gagamitin nyo itong code na to, kailangan nyo lang palitan actually ay lines 3 and 5. Sa line 3, papalitan nyo lang yung mesh grid kung iba yung x at saka y values na gusto nyong pag-aralan. Kung gusto mo halimbawa, -10 to 10, yung x components, tas yung y components ay 5 to 10, so kailangan mo lang itong palitan accordingly. Tapos pag naiba na yung ODE mo, syempre, papalitan mo na rin si F kasi si F yung right-hand side ng ODE mo. So kaya saka mo siya ilalagay dyan. Right? And then, just leave the rest as is. Wala na kayong ibang babaguhin. Lines 3 and 5 lang yung babaguhin nyo. Then when you have this on your MATLAB screens, or press F5. If I press run, mag-run siya, mag-generate ng direction field. Gusto kong ginagamit itong quiver plot kasi merong arrows na kasama para alam ko kung paano mag-move, right? So if I'll do this, right? Kung kukunin ko yung solution, okay, hold on. Loading pa si Teams. Alright, kung gusto ko makakuha ng isang particular solution, iti-trace ko lang yung behavior ng curve. So mula dito, may point ako dyan, tapos may point ako dyan, tapos dapat horizontal dito yung tangent line. So dapat pa ganito siya. Tapos ito pa ganun din. Yung mga lines na yan, sila yung mga tangent lines. So iti-trace ko lang siya dyan. Tapos ito pa ganyan. Mag-start siya dyan. So makakabuo ako ng circle. Gusto ko yung quiver kasi meron siyang arrow. Sabi kung paano yung flow. Kaya siya direction field actually. Kasi gusto nating malaman yung direction ng paggalaw. And then ito naman, pag ganun, mag-meet nga lang sila dun sa gitna. So you will see you will have circles here. Nagmukha siyang ellipse kasi hindi equal yung scaling sa x-axis at saka sa y-axis. MATLAB tries its best to give you the best scaling for x and y, which are not necessarily equal to each other. Okay? All right. Any questions with that? So probably what you'll do, pag tapos na kayo sa homework, try to play with the code that I shared with you and try to recreate some of the examples. Okay, marami pang examples dun sa slides, and we'll again on Wednesday next week, right? Pero pwede niyo na simulan paglaruan yung ito y prime equals x squared minus y. So dun sa quiver plot, dun sa MATLAB code, ang f nyo ngayon ay x dot caret 2, right? Basta gusto nyo gawin ng isang operation component-wise, lalagay nyo yun ng dot, tapos caret for exponentiation. Kasi nga x squared, gusto nyo erase si x to the second power, kaya lang si x ay vector dun sa MATLAB code natin, kaya dapat dot caret tapos 2 minus y. And then run the code, and then see that you'll get something like this. All right? And this is where we'll start on Wednesday. Okay? So, questions? Or nating lecture? Too much info? Pero okay lang yan. Madali lang naman yung first part, di ba? Nag-algebra saka simple calculus lang naman tayo. All right? So, I hope that's fine. For the weekend or before we start on before our meeting on Wednesday, all right? So you can do the homework, of course. Deadline is on the 21st, 9:59 a.m. That's right before our lecture. And then try to play with the MATLAB code that I gave you. And then if you get some, if you encounter some problems, just let me know. Okay. So lahat ito ay nasa canvas na. So yeah, ayan, nakita na ni Crysel. Even the MATLAB code, so you can download it there, you can play with it, and then let me know if you have some questions, all right? So we'll stop here and let's call it a day. Yate, wala na akong klase today, pero may meetings pa. So I hope you guys can now relax, or kung may klase pa mamaya, konti na lang naman, ano? So happy weekend, everyone, and let's see each other again on Wednesday. Bye, guys.
Bye, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you po, sir.
Yung mga nag-recite pala ng verbal lang, paki-comment naman sa chat box. Thank you.